So we're going to start off by looking at the graph of a radical function. And the function we have is y equals negative 2, square root of x minus 3 plus 6. Right? Now keep in mind order of operations. We would subtract 3 from the x, do the square root of that, multiply by negative 2, and then add 6. Right? This is its graph. You notice that it's a half a parabola, but it's a horizontal parabola, not a vertical parabola. Okay, you're actually going to run into these. Well, actually, I don't even know. You may run into these next year. We're going to say that this parabola has a vertex. What is the vertex of it? Or where is the vertex?
3, 6.
Okay, yeah. So let's go with that. We'll go with 3, 6. What restrictions are there on the variable x? So what do we know about x minus 3, let's say?
Can't be negative.
Yeah, so x minus 3 has to be greater than or equal to 0. What does that say about x? Yeah, greater than or equal to 3. Right, because we know we can't have a negative underneath the radical sign, right? So restrictions that we've dealt with, for rationals, you can't have a 0 in the denominator, right? So when we're doing rational equations, we always factor the denominator, look at the factored form, set each factor to 0, and then say, all right, these are non-permissible values. And here, it's actually going to be a range of values, right? Any value of x that's bigger than 3 will make this negative. Okay. Oh, actually, sorry. X has any value of x that's less than 3. So the restriction is that the x value has to be bigger than 3 or 3. Okay, so 4 is fine, 5 is fine. Anything less than 3, no good. Right, you'll end up with a negative under there. State the domain and range of the function. So what's domain? Set of all x such that? Yeah, x is greater than or equal to 3. And we can also add that x belongs to the reals. And what will the range be? So what can we say about the y values? Yeah, can y go? So y is less than or equal to 6, right? Because we're starting here. That's the vertex. From there, we're going down. Okay. So as I get really, really big values here, it's a half a parabola. So as I get really large values for x, then the square root is going to become large as well, right? I mean, it's still smaller than the number, but it's still large. Multiplied by negative 2, it becomes negative, and then you add 6. So we can see that, well, the 6 is going to come about if this is a 0, right? I put a 3 in here. 3 minus 3 is 0. The square root of 0 is 0 times negative 2 is 0 plus 6. After that, all these values will become negative, right? Since root x minus 3 has to be a positive value, right? We can only take the square root of a positive. So then y is less than or equal to 6, and y belongs to the reals. How does the domain relate to the restriction? They're the same, right? Use the graph to find the value of x when y equals 2. Okay, so what do I do? Go to 2. Find that point and then get the x value that goes with it. So what is the value of x? Okay, so x equals 7. So when y is equal to 2, and we do that by going along the y equals, right? This is where y equals 2, this horizontal line. Here's like y equals 5, etc. Show this on the graph. There's the point, and the point is 7, 2. solve the equation negative 2 root x minus 3 plus 6 equals 2 algebraically. Hint, first isolate the radical root x minus 3 and then square both sides of the equation to eliminate the radical sign. Okay, so follow this carefully because we're going to be doing this for the rest of today, and that's your homework for today and tomorrow. This is the end of the unit basically, right, is today and tomorrow. Solving radical equations, Wednesday review, Thursday test. Okay, so we want to solve this algebraically. And the idea is let's get this isolated. So the first thing I'm going to do is get rid of the 6. I'm going to subtract 6 from both sides. Okay, so subtract 6 from both sides. Then we're going to divide by negative 2, right? Make sure it's negative, so we got root x minus 3 is equal to 2. So when I've isolated a radical, right, that's the whole thing in solving radical equations, is get the radical by itself. Then we square both sides. What's the square of this? X minus 3. What's the square of 2? 4. So x is equal to 7. Okay, so we've shown the work. How does the answer in question 4 compare to the answer in question 5? They're the same. Yeah, 90% of the time the answer to this question is they are the same. Yeah, not always. All right, maybe it's 95% of the time. Most of the time you just say, hey, look, they're the same. Now solve negative 2 root x minus 3 plus 6 equals 0 algebraically. Use the method from question 5. Okay, so same deal. Negative 2 root x minus 3 plus 6 equals 0. So we want to isolate the radical, right? We're doing order of operations in reverse. So in this case, we're adding and subtracting first. That's the last thing you would do. So negative 2 root x minus 3 is negative 6. Divide by negative 2. Square both sides to get rid of the radical. And then add 3 to both sides, we get x equals 12. Okay, so an algebraic solution of a radical equation, right? It's an equation because it's equal to something, right? In other words, there is a value of x. We're not simplifying radicals. So like rationals, right? Rationals we added and subtracted, we multiplied and divided, and then we solved equations. And there's a different thing you do in those cases. Radicals, kind of the same deal, right? We can simplify radicals. We can pull x cubes out from under, a cube root of, if we have an x to the 6th. We could pull that out of a cube root and stuff like that and get a simpler expression. But these are equations, right? They're equal to something. Equals 0, equals 2, equals 10, whatever. They can be solved and you can find a value of x. So in this case, yep, done. Can you find the same answer to question 7 by looking at the graph? Show the answer on the graph and explain how you use the graph. Okay? So if we're doing the graph, what do I want this? Remember, this is the curve. I want it equal to 0. So we're going to go back to the curve, find y equals 0, and get the solution, which is x equals 12. Okay, so remember, this is what y is. So when you write this equals 0, it's like writing y equals 0. Right? Or when you write that is equal to 2, it's like writing y equals 2. What's the x value that goes with that? Show the answer on the graph and explain how you use the graph to find the answer. So we looked for the point on the graph. That had a y value of 0. Okay, one more, just because we want lots of practice in solving these, right? So we're solving this same one a few times over, but so negative 2 root x minus 3 plus 6 is equal to 8. We're going to subtract 6 from both sides. We're going to divide both sides by negative 2. We're going to square both sides. And we are going to add 3 to both sides and get x equals 4. All right, and now it's asking us to do something a little bit different. It's saying verify your answer to question 9 and show your work. Okay, so if we're going to verify this, I'm going to do a t-table. So the left side of my equation is this. Negative 2 root x minus 3 plus 6. And I'll leave more space there because the right side is just equal to 8. So I'm just looking for an 8. We're going to plug in the x value. Negative 2 root 4 minus 3 plus 6. Negative 2 root 1 plus 6. Negative 2 plus 6, which is 4. And they're not the same.
How did you, I don't get how you, the square root of 1.
Square root of 1 is 1. Square root of 4 is 2. Remember, the radical sign means the positive or principal square root, right? We don't worry about plus or minus. So when I'm doing root 9 with the radical symbol, it's just 3. Right? We don't have a negative 3. So here it's root 1, which is just 1. What happened in question 10? Did your work check? No. Refer to the graph and explain why. So no, it didn't check. But I can spell check, apparently. Did not check. Refer to the graph. So we said that x was equal to 4. Let's go back to the graph and look at where x equals 4. So when x equals 4, y is equal to 4. That's actually what the check showed, right? We put in a 4, we got a 4 out, not an 8. So where's the 8, right? The 8 is this sort of phantom branch that isn't here. Right? That's not part of it. That's not part of the square root because this symbol means positive. Right? So when I have a 9 under there, it's not plus or minus 3, right? It's not like x squared equals 9, so x is plus or minus 3. It's like the root of 9, which is positive 3. So we don't have an upper branch to this parabola where the answer 8 would lie. Okay. So what we did is we found an extraneous solution. Okay, refer to the graph and explain why the answer you found is not on the graph, right? It didn't check, it is not on the graph. As we only have half of a parabola. What's called half of a horizontal parabola. And then there's the blurb, right? The answer you find in question 9 is called an extraneous root. An extraneous root is a solution that's found algebraically, but that does not verify the equation when you check using substitution. Extraneous roots are common in radical equations and must always be rejected. If an equation has only extraneous roots, then it has no solution. Okay? So it's just like radicals, right? When we do radicals, we're solving them. The method of solving them sometimes introduces extraneous roots. And we have to say, no, that won't work here. Right? And sometimes it's context-based. You know, we're finding a distance, and we get the distance is plus 4 or minus 8. We have to reject the minus 8. Right? We say, well, you can't have guidance. Okay, you can't have x equals negative 8 in this case because you're solving for a distance, right? So it's context-based. Or you're solving for an area and you get a negative area or something like that. Or time, and you get a negative time. Those roots are extraneous. in radicals, okay, by the act of squaring both sides, we ended up introducing an extraneous root. Okay, we got about 6 of these to do. They're all a little bit different. We're going to solve the following 3 radical equations. So that's A, B, and C. And then there's more. Show, check, and state the solution. Okay, so we're going to solve it. We're going to check it. And we're going to state the solution, right? Eliminating any extraneous roots. Okay, so starting from this, first thing I'm going to do is subtract 6 from both sides. All right, so your first step in getting the radical isolated is to add or subtract the same number to both sides. In this case, 6 is being added. We're going to subtract 6 from both sides. Then we divide by what? We divide by -3, and we get root of x minus 4 is equal to 7. What do we do next? Square both sides, so we get x minus 4 is equal to 49. And we isolate the x by adding 4 to both sides, and we get x equals 53. So at this point, we're at I think the solution is x equals 53. But is that the solution, or is that an extraneous solution that was introduced by squaring both sides? So let's find out. The left side of my equation is 6 minus 3 root x minus 4. Right side is equal to -15. We're checking a value of 53. So we're going to go 6 minus 3 times the root of 53 minus 4, which is 6 minus 3 root 49, which is 6 minus 21, which is -15. Left side and right side are the same. Checks. So the solution is x equals 53. Okay, any questions? Okay, next one, similar method, right? There's nothing to add or subtract, right? It's just 2 times the root of x plus 3. So we can't do anything with that x plus 3 until we square both sides to get rid of the radical sign. So we get x plus 3 is equal to -2. We square both sides and get x plus 3 is equal to 4. We subtract 3 from both sides and get x equals 1. We want to check this. Left side is 2 times the root of x plus 3. Right side is equal to -4. 2 times root 1 plus 3. 2 root 4, which is 4. And that doesn't check. So the solution is there is no solution. Or the empty set. This is a way of saying the empty set, right? That you've got a 0 with a slash through to say this is empty, so set. Or I think you could also say just a set of brace brackets with nothing in there, right? Just saying the empty set. So you can state as there is no solution, it's the empty set, it's the empty set. Now, when did I know there was no solution? Or when could I have known there was no solution? could I know right here at this line, could I know there's no solution?
Yes.
Yeah, because this says the square root has to be negative, but we know that this radical sign says the positive or principal square root. So this has to be positive, this side is negative, so at this point here, we could have gone in and said there is no solution. Okay, in other words, the square root of something must be positive, this square root is negative, and you could add since, root of anything must be positive. Or I guess we could say root x plus 3 even, right? So we could say no solution since the square root of x plus 3 must be positive. Okay, questions? So A, basic, fairly straightforward one, right? You're just adding a number to both sides, or subtracting from both sides, you're dividing, you're isolating the radical, all right? If you can help it, you don't ever want to have a number on here when you're squaring, right? Because you're going to forget to square it or something. So if you can help it, get the radical isolated, single radical, nothing added or subtracted from or to it, nothing multiplying it, square both sides. At this point, you're going to actually check to say, hey, wait a sec, it's negative. It's not going to solve, right? And I can just state at this point, there will be no solution. Done. Okay, and that's a perfectly valid thing to do. Okay, next one. We've got the radical isolated, but this is going to be a little more complicated, right? This radical itself is a quadratic. The right-hand side is a binomial. It has to be squared as well. Okay, so our step is we're going to square both sides. When we square a square root, we just basically remove the radical sign, right? So this side becomes negative x squared plus 4x plus 4. And when I square x plus 2, what do we get? So if you want, you can use your scrap paper, go off and, foil it out or multiply it out. We get x squared plus 4x plus 4. So this is x squared plus 4x plus 4. In order to solve this, we're going to get everything to one side, right? If you're solving a quadratic, you want to get it equal to 0, right? Because then we can factor it, or we can use the quadratic formula to solve it. But we can't solve it if we have x squareds on both sides or numbers on both sides, right? It has to be equal to 0. So moving stuff over, this will become 2x squared. That'll be 0, that'll be 0. So 2x squared is equal to 0. Which means that x squared is equal to 0, which means that x is plus or minus 0, but we never say that for 0, right? It's just 0.
I thought it was supposed to be negative 4.
Okay? If we had like 2x squared equals 18, it would become x squared equals 9. And this is not a radical, right? So when we solve this, we're going to get a plus or a minus, but not for 0, right? It's just 0.
You don't have to fold like x squared plus like 4x plus 4, for example.
Yeah?
Would you factor it and then you got 2 different answers?
I would not do anything until I had everything on one side and 0 on the other
Like
side.
say if like you put it all on one side instead of getting just 2x squared, then like you go ahead.
If I had other stuff, then I would factor it and I'd get my 2 solutions. And then I have to verify both solutions, right? So we still have to check. Okay, like, I don't know if this is right. I mean, you can sort of see if you put a 0 in there, that's going to be 0, 0. You get square root 4 is equal to 2, which is true. So 0 will check, but we should formally do that. So, right.
If you moved it to the other side and got negative 2x squared, then you couldn't take the square root of a negative.
That would be the next 2 lines. I would divide both sides by negative 2, and then I would get, doesn't matter if it's plus or minus, right? So if it's negative 2x squared, I'm dividing by negative 2. If it's positive 2x squared, I'm dividing by positive 2. Okay, let's check. So this time we're substituting in a 0, right? We get 0 plus 2, which is 2. Can you guys just talk a little quieter, right? I'm obviously never going to stop you from talking. Just keep it down so I can't just whisper. You, trust me, your ears are a lot better than mine. You should be able to talk to each other so I don't hear you. And you won't bug the people around you, and everybody will be happy. You'll be talking and not disturbing. Now, this negative x squared, right? No matter what x is, if it were any number other than 0, it would be a negative, right? It's not this, right? It's not negative x squared, which would always be a positive. It's the negative of x squared. Order of operations says you're going to square the number first, then apply the negative to it. In this case, it's 0, it doesn't matter, right? Negative 0, positive 0. So this is square root 4, which is 2, and that checks. Okay, remember, it's square root 4, which is a positive number, right? That radical symbol means the positive or principal square root.
So, why do you group the x plus 2 together into a binomial? Because if you don't, you get x plus 2, which also works.
Yeah, because
Sorry, x equals 2.
if you don't square it, you won't get the right answer to any other thing. The only reason this worked is because the x's are canceling out and the x squared is just, This is a special case.
Okay, so
Okay.
normally you'd have to.
Well, you always have to square it. Well, if we didn't square this,
No,
you're saying it would work out like
no,
this?
like I squared the whole thing.
Yeah.
But I kept x and 2 as individual terms. Like I didn't make it x plus 2 times x plus 2. I just got x squared plus 4.
No, that's totally wrong.
But the solution works. X
Right,
equals
hang
2.
on. 3 terms.
Okay.
Okay, so squaring this binomial, right, you get 4 products, that's 3 terms.
Right.
Okay, let's move on. D. Now in this case, okay, what's different now? Well, so here we had the radical isolated, here we don't, so we have to isolate the radical. This will become x minus 2 is equal to the square root of x plus 10. We need to square both sides. The left side will be x squared
X plus 10 plus 4.
minus 4x plus 4. Okay? So remember, you're squaring a binomial, you're getting 3 terms, right? You're getting 4 products, which will collect into 3 terms. Okay? We have the radical isolated here, so when we square it, then it just comes out as x plus 10. We're going to move everything to the left side, because I've already got a positive x squared. So we'll go x squared minus 5x minus 6, right? Because we're subtracting x and we're subtracting 10. Okay? So you want to be careful about your squaring and all of this stuff, right? Because if you're not, then instead of getting something that factors, so word of advice, if you're starting to want to use quadratic formula and it didn't say round your answers to the nearest or give answers as exact values, then you may have messed up, right? And you might want to go back and look at it again. So hints for things where you would end up using quadratic formulas, would say express your answers at exact value or something. Okay, so what is this? X minus 6, x plus 1. Now, anytime you factor, check it, right? X squared plus 1x minus 6 plus 1 minus 6 is minus 5 minus 6. Okay, so I've got the right factorization. This tells me that x is equal to 6 or x is equal to negative 1. All right, now we need to check those because we don't know, maybe. Well, yeah, does the negative, well, the negative 1 won't be a solution. Why not? Because look at this side, right? You're taking the square root of something, which is going to be positive, and then you're adding 2 to it. So I'm saying, let's take something that's positive, let's increase it by 2, and let's have it be equal to negative 1. Yeah, something that's positive and then gets bigger positive, it's not going to be equal to negative 1. Okay? So we can see we're going to have to reject that solution, right? But we need to show the check. So let's check them both. So the left side is x. Right side is root x plus 10, and then plus 2, right, outside of the root sign. So let's check the 6 first. So this is the root of 6 plus 10, plus 2, 4 plus 2, which is 6. So that checks. And let's run the check on the other one as well, which we figure will not work. So left side is -1. We get -1 plus 10 plus 2, which is root 9, plus 2, which is 5. So I'm not surprised it didn't check, because I kind of knew just by examining it that, hey, I can't take the square root of something, get a positive number, and add 2 to it, and end up with -1. Right? Not going to happen. Why did that solution come out? Basically because we've squared both sides. Right? Kind of like with the absolute value stuff, where we get these two answers, but then one of them, doesn't check. Okay, so it's important that we check. State your solution. The solution is the solution. X equals 6. You might want to put a little x through there. So I want to see them both, right? If you're doing this, I want to see this. I factored. I want to see here are my solutions or my potential solutions. Now I've gone and checked them, right? And if we don't ask you to check, you still need to run some kind of a check, right? And you can actually do this one in your head. You say, well, 6 plus 10 is 16, root 16 is 4, plus 2 is 6. Yeah, okay, so the 6 works, right? And the -1, yeah, that can't work. So even if we don't ask for an explicit check, it's like solving a rational equation. If we don't explicitly say, you must check your answers, you still have to check your answers, right? But you're basically checking them to say, is my solution one of the non-permissible values or not, right? If it is, then I need to reject it. All right, this is not going to be fun. This is a double radical, right? We have two radicals. What you don't want to do is you do not want to square both sides right now, okay? Because you'll have a really complicated expression, right? You'll get the 2x plus 6, because that's root 2x plus 6 times root 2x plus 6. You'll end up with a -9 times x minus 4, which is the square of the second term. But it's not a difference of squares, right? Middle terms don't cancel. You'll end up with -6 root 2x plus 6 times x minus 4. You don't want that to happen. Okay, so how do we avoid this? When you have a double radical, you move one to the other side. Okay, so when you have a double radical, you move it to the other side. When two radicals, put one on each side. All right, next thing is make sure that you square both sides properly, right? So the root 2x plus 6 squared, that's pretty easy, right? It's 2x plus 6. What's this side?
9x minus 36.
Yeah, 9x minus 36, right? And we'll do that. Let's do that in two steps. So we'll say it's 9 times x minus 4, right? 3 times 3. So I'm squaring this side. I'm multiplying it by itself. So if you want to, just think of it as this, right? It's 3 root x minus 4 times 3 root x minus 4. Right? Bracket there. Okay, and just do this way. It's 3 times 3 is 9. Root x minus 4 times root x minus 4 is x minus 4. So it's 9 times x minus 4. And again, if you just want to write it as 9x minus 36, that's good. Okay, but that'll be our next step. So 2x plus 6 is 9x minus 36. This is linear, right? There's no square, there's no x squared. We're going to get a single value for x, right? A single solution. And we're going to end up with 7x. And we're going to get negative 42. No, positive 42, right? Sorry, move that over there. 7x, move that over there. So 7x is 42. And x is equal to 6. Okay, is this true? Only one way to find out is we have to verify it, right? We have to substitute it in. Okay, remember, no guarantees that anything is true because we are squaring both sides.
Use the original one.
You always use the original one, yeah. The reason is if you made a mistake in simplifying and you go in there, If this should have been, like a -3 or something, which then wouldn't work, you'd just say, hey, no solution, right? If that ended up as -3 times that, you'd say no solution, right? Because you could say, I got a square root here, which is positive, and this will be positive, that would be negative, there's no solution. But if you make a mistake on this line and you go to verify there, you'll verify that you got the correct solution to the incorrect equation. We want to verify we've got the correct solution to the original equation. All right, so all we're going to do is we're going to put in a 6. It's not quite that big of a -3 root 6 minus 4. Okay, so we end up with root 18 minus 3 root 2, which is 3 root 2 minus 3 root 2, which is 0, and it works. And so let's state that at the bottom, right? So the solution is, so anytime you're solving any equation, I don't care if it's absolute value, radical, rational, whatever, stick a line at the bottom and just say the solution is. That's the first thing I'm going to look at, right? Did they get it right? Yes. Okay. Is there work that justifies that correct answer? Yes, there is. All right. Things look good. Yes, they do. Good. Full marks. Okay. If it's hidden, if it's done in pen and it's crossed off and there's stuff here and there and there's no flow to it that it starts off on the right side, goes over the left side and then back or something like that. If you do end up with something like that and you did write it in pen, then rewrite it on a piece of paper. Just put an X through it and say see attached sheet, and write up a nice neat solution at the end that you can attach. Easy to follow and easy to mark. Okay, any questions? One more, the most fun one. All right, this is more fun than the last one because we have double radicals, and when we square both sides, we're still going to have a radical. And then we're going to square both sides again to get rid of that radical. Okay? So this is as bad as it gets in that we have two radicals. You definitely do not want to square both sides now. Okay? It's way too complicated. So our first step is, let's just take this and do this. Okay? So if there's ever more than one radical, you need to get one radical on each side, even if one of them gets a number with it. Yep.
Can you just add like 2x minus 1 to that side and then just plus 2?
If I add something to one side, I have to add it to the other side. Right? You gotta maintain the balance. Now we're going to square both sides. Okay, this side's easy. It's 4x plus 5. This side, if I'm going to square it, I'm going to go over here and do it, right? You can do it this way. You can just square it if you know. Okay, so this is 2 times 2 is 4, plus 2 root 2x minus 1, plus 2 root 2x minus 1, plus 2x minus 1. Right? We're squaring a binomial. This binomial has radicals, but it's still FOIL, right? The first term's 2 times 2. The outer, 2 times the root of 2x minus 1. The inner, 2 times the root of 2x minus 1. And the last, root 2x minus 1 times root 2x minus 1. So the quick way to square this is you square the first term. You take this times this, which is 2 times root 2x minus 1. Okay, and you double it to give you 4 times root 2x minus 1. And then you square this. Okay, so we still have a radical courtesy of this 2. Right? Because it gave us a binomial on the right-hand side. And when you square a binomial, you get 4 products, right, which collect into 3 terms. All right, what we need to do, let's just simplify it in place. So I've got 4 minus 1 is 3. So I got 3 plus 2x. All right, let's just back up a few questions, right? what we're going to do is we're going to move the x's and the numbers to one side. We're going to isolate the radical. So here we are. We could be doing a question, and this question could have come up in part C or something. And just like this, and we'd say, okay, I need to move stuff over. So I'm going to get 2x. I'm going to get plus 2. And I'm going to get, that's 4 times the root of 2x minus 1. Okay, can we simplify anything? You'd say, well, they're all even, right? I got 2x, I got 2, and I got 4 times something. So I could divide everything by 2. If you don't, it's not a tragedy, right? It just means you're squaring bigger terms than you have to. So whenever we're doing any of this stuff, right, it doesn't matter, radicals, absolute values, anything where you have expressions, take the opportunity to simplify when you can. It'll just make things simpler in the end. All right, so what we're going to do is I'm just going to reverse sides here. I'm not going to divide by 2 because I don't want to square the x plus 1, square it, and then over 2 and have to worry about that. Okay? I'll just remember when I square the left side, there's going to be 4 times 2x minus 1. Right? So we square this, we got to square the 2, gives me a 4, and we got to square the root 2x minus 1. And this will be x squared plus 2x plus 1. Okay, we're squaring a binomial. Right, so you're going to get 4 products collecting into 3 terms. Now what? I might as well just get this over with. So let's just go 8x minus 4. I don't want to divide by 4 because if I do, then I just end up with this over 4. And how do I solve that, right? So let's just expand that out. Okay, now we're going to move everything over. So we get x squared, subtract 8x, gives me minus 6x, add 4. And that'll be equal to 0. So we're solving a quadratic. When you solve any quadratic, you always isolate the x squared, the x, and the number on one side, set it equal to 0. You then factor, which this does. So, oh, there's an x there right on the 6. Minus 6x. Look real funny. So x minus 3, nope. X minus 5, x minus 1. Okay, x squared minus 1 minus 5 is minus 6x, and then plus 5, right? Okay, same deal, right? You always check your factorization because if you get stuff wrong, it just turns into a lot more work than maybe it needed to be. Although in this case, we're almost done, so. Okay, and we solve, we get x equals 5 or x equals 1. We've solved, but we know that when we solve absolute value equations or radical equations or rational equations, that the solution method will sometimes introduce non-permissible values or extraneous roots. So we've got 5 and 1. I'm just going to move back up here so we can check. Okay, so here's the check. The left side is the root, right? And we're just leaving the left side as it is, minus root 2x minus 1. And the right side is pretty easy. That's just equal to 2. Okay, and we want to try 5. So 4 times 5 plus 5 minus root 2 times 5 minus 1. Okay, so 5 checks, right? 5 checks. Okay, we also need to check the 1. Right side is 2. We want to check when x is 1, so 4 times 1 plus 5 minus the root of 2 times 1 minus 1. So root 9 minus root 1, which is 3 minus 1, which is 2, and that also checks. Okay, so both solutions in this case, x equals 5 or x equals 1, are both valid solutions. Okay, if we didn't say to check, we still expect that you will, cross off any extraneous values, right? Or in the end, what I'm going to do is write down the solution, right? So down here, having checked it, I'll then say the solution is okay? You write it out in a sentence at the end, it leaves no doubt, okay? I don't look at it and say, well, did you get rid of the extraneous value? Like the minus 2 is extraneous or something. And is it crossed off there? It's hard to see if it's crossed off, right? This way you're just stating one sentence at the end. Here is my solution, right? X is 5 or X is 1. Which should hopefully match up with the answers down here. You can express your answers as set. So the set consisting of 53. This has no solution. Empty set. This was 0, 6, negative 1 was an extraneous root. This was 6, this was 1, and 5. Okay. We don't actually need those answers down there because we've verified every answer that we gave. Right? But again, this is just a different notation. So it's the set consisting of 1 and 5. Do not write this. What's this? It's an ordered pair. It's the point 1, 5, right? It's x is 1, y is 5. We don't have any of that going on here, right? We're solving simply for values of x. All right, so I'll take a sentence. The solution is x equals 1 and x equals 5, or x equals 5. The solution is x equals 53. The solution is, there is no solution, right? Or the solution is 6, and the negative 1, you've checked, you've shown it's extraneous, put a little x through it, but also state the solution. Okay, questions on